What makes ceramics vulnerable to thermal shock? Imagine pouring hot water into a cold ceramic mug and hearing a sudden crack. That's thermal shock at work, and it shows how ceramics can be surprisingly fragile under rapid temperature changes. Ceramics are known for their hardness and resistance to chemicals, but they have a weakness when it comes to quick heating or cooling. To understand why, we need to look at what happens inside the material during these sudden temperature shifts. When ceramics are heated or cooled rapidly, different parts of the material change temperature at different rates. The outside cools or heats faster than the inside because ceramics do not conduct heat well. This uneven temperature distribution causes the surface to expand or contract faster than the core. Since ceramics tend to have high coefficients of thermal expansion, they want to change size significantly with temperature. But because the inside and outside are changing at different speeds, internal stresses develop. Ceramics are brittle, which means they don't bend or stretch much before breaking. When these internal stresses become too high, cracks form. Usually, cracks start at the surface where the temperature change is most intense. Once a crack begins, it can quickly grow and lead to the entire piece breaking apart. The likelihood of cracking depends on several factors, including the ceramic's properties and shape. Materials with lower coefficients of thermal expansion, like fused silica or cordierite, handle thermal shock better because they don't want to change size as much. Poor thermal conductivity makes things worse because it creates larger temperature differences inside the ceramic. If a ceramic has high fracture toughness, it can resist crack growth better, even if a crack starts. Shape and thickness also matter. Thin, smooth, rounded parts are less prone to cracking than thick or sharp-edged shapes. Porous ceramics can sometimes resist cracking because their pores stop cracks from spreading easily. But generally, ceramics with high density and high strength are more vulnerable to thermal shock because they don't deform easily to relieving internal stresses. In real-world applications, thermal shock can cause failures in many ceramic products. For example, a ceramic coffee mug filled with boiling water can crack if it's not designed to handle rapid temperature changes. In industry, ceramic components in engines or furnaces can crack or break if exposed to sudden temperature shifts. Engineers choose materials with lower coefficients of thermal expansion or higher toughness to prevent these failures. They also design parts with rounded edges and thinner profiles to reduce stress points. Understanding why ceramics are vulnerable to thermal shock helps us see why some products fail unexpectedly. It also guides us in designing better ceramics that can withstand rapid temperature changes, making them safer and more reliable in everyday use and industrial settings.